Sometimes you need to check whether a type extends itself. What? Since I'm a very creative person, I have created two interesting types, cat and dog, to illustrate some TypeScript semantics. So they share name property, which is a string, and both have exclusive properties, which are methods, meow for a cat and bark for a dog. Never mind what they accept, never mind what they return. Anyway, what we want to have is a type animals, which is going to be a union of the cat and the dog. And let's say that what we want to do is to create a type which would be still a union, but that would not include the name or whatever that is basically shared across them. So let's see what would be the animals without the name. So we would obviously run the built-in omit type utility, which accepts the union or the object type and whatever are the properties that we want to exclude. So animals, and we want to remove the name property. Now, what you would expect to get actually would be a union of an object with a meow method and another object type with a bark method. But what we see is actually an empty object. So what is going on here? So what map types are doing in this case is that if we pass a union of object types and TypeScript tries to iterate over the keys of the union, in this case, the union object type is not getting distributed. In other words, when we try to iterate over the keys, it would basically take only the common properties. So actually, this is the, let's say, first step of the problem. So if we want to see what are the keys, type keys of animals, we would basically get only what is being shared. Now, in some situations that would be okay, but in some situations it would be a problem since we might want to also get the meow and bark. So what we need to do is to enforce the union to get distributed. So let's create a distributive omit, distributive version of the omit. So basically, this is going to be omit as it was, but and we're going to reuse the type parameters with the generic constraint. So by the way, omit is basically using here the k extends string, number, or symbol, but that basically comes from property key, which we're going to reuse. So basically, this distributive union is not doing anything interesting so far. And the trick is, dear everybody, to check whether T extends itself. So does T extend itself? Of course it does. Like, how could it not extend itself, right? It doesn't make any sense. So where would we walk into the never branch? Well, never. That's the whole point. By the way, it doesn't make a difference whether we would check whether T extends unknown or T extends any or T extends T, whatever we put here. So if you ever stumble upon such a piece of code in TypeScript, you could think like, what a heck of an idiot wrote that? Well, most probably that was not an idiot. So let's see how this works in practice. So let's create one more type, animals without name. So let's call it distributive animals without name. And instead of using the traditional omit, let's put distributive omit. And as we can see, yeah, that does make a difference. So what is going on here is that a single omit would, just a standard omit, would have to treat the, when the iteration takes place over here, it would need to grab what are the keys of a union, and that is basically a set of the common properties. But if we distribute the union using, basically enforcing it by using a conditional type, and we are not filtering anything because this condition is always true. So we are always walking into the truthy branch. But only the fact that we are syntax-wise using a conditional type, we are not getting keys of a whole, of a union of the object as a whole, but we are distributing the union of objects, and each member is going to run through this omit. And for this reason, each member is going to have applied the omit separately, and the result is going to build into a union back again, as it always happened with distributive types.